LLMs are advancing quickly and they are offering immense potential. As a result, businesses are employing LLMs for addressing specific needs and harnessing their power. There are over hundreds of applications driven by LLMs already in the market and in the use. And some of the popular examples being GitHub Copilot. It's the world's most widely adopted AI tool for developers. It can write the code for us on a fly. Today, more than 37,000 plus businesses and one in every three Fortune 500 companies have already adopted GitHub Copilot. It enhances the productivity of the developers by more than 50%. The next one is 10web.io. 10web.io lets you create a website in seconds just by answering a few questions. Today, with the power of LLMs, anyone from non-developer background can build a website instantly without writing a single line of code. The next one is Jasper.ai, an AI writing assistant powered by LLMs. With Jasper.ai, you can create a high quality content for blogs and email campaigns instantaneously. Time has quickly changed, isn't it? Earlier, it would have taken nearly 2 weeks of effort to write a high quality blog and then editing it and then seeing whether it is relevant or not. But in today's world with LLMs, it hardly takes a few seconds to write a high quality blog. The next one is Chat PDF. Chat PDF lets you chat with any of the PDF documents, be it research papers, blogs, books, etc. Picture being able to upload your favorite book and then having a chat with it and ask about the roles, the characters. Isn't that cool? Likewise, there are many applications powered by LLMs today across different domains like healthcare, finance, e commerce, so on and so forth. So, the question is how can we build these kind of LLM applications? And that is what we'll discuss in this particular course. So primarily, there are four different methods to build LLM applications. The first one is called prompt engineering. The second one is retrieval augmented generation, popularly known as RAG. Third one is fine tuning LLMs. And the fourth one is training LLMs from scratch. These are the four different ways to develop LLM applications. Prompt engineering is one of the simplest and most commonly used methods to build an LLM application. And in this lesson, we'll explore the concept of prompt engineering and why it's such an important concept. But before understanding what prompt engineering is, let's understand what does a prompt refers to. We know that LLMs have been trained on massive data sets and are capable of following the instructions from the user. It gains the knowledge of the events, facts, or any other information present in the training data. And we can access this knowledge present in the LLMs through prompts. So, prompt is a text given to the LLM as an input for getting the desired output. A prompt is like telling the LLM what you want it to do or answer for you. Simply enter what you're looking for, and the LLMs will provide you the information which you need. So, now let's go to the ChatGPT interface and interact with it through a few prompts. As you can see, this is the ChatGPT 3.5 version which I'm going to use. And so let's say the first example which I want it to do is to make a content strategy for a newsletter featuring free local weekend events. So let's say I want to create a new newsletter, or I am already running a newsletter, but I want a better content strategy. Let's try and give this prompt to ChatGPT and see what it does. So as you can see, it starts giving me the output. It says me to define the audience, the frequency, define the newsletter sections, the format, engagement and interaction, theme newsletter, local partnerships, email design, consistent branding, personalization, promotions and giveaway, legal consideration, adaptability, email automation. Wow, mind blowing, right? So with just one prompt, it gave me almost all the knowledge which I need to actually create this content strategy and maybe implement it. So you can see the power which it gives for someone and the productivity gain which it might create, right? Let's try a new example. So again, I'll just go to a new chat, and this time I'll, let's say I want to start a new brand of snacks, and let's see if we can use it to brainstorm a few ideas. So I'm saying I want to start a new brand of food snacks. Can you help me with a few ideas about an exciting brand name? Let's see what it does. Wow, now look at the amount of creativity. So it was able to create these 20 brand names, and some of them look really interesting. Savory Spell, Nibble Nook, right? So it clearly knows what I am looking for, what is the thought. And let me make it a bit more interesting. So I would just go and edit my prompt. So this is something you can do in the interface. And I say that I want to start a new brand of healthy food snacks. So I'm changing that, and let's see what it does to the output, right? So again, with just a simple prompt, it was able to create 20 new names or a lot of new names, which now focus on health. So again, the amount of creativity which it packs is probably more than what a few brand specialists would do in a much longer time. So that's the kind of power which it creates. Let's take one more example. So again, I'll start with a new interface, and this time I'll ask it to give me a learning path. So what I'll ask it is, can you create a learning path for a fresh non computer science graduate who wants to enter into data science? And I'll just say provide step by step path for the same. And let's see what it does. Right? So it's just amazing that it started from prerequisites. So very clean structure. You can see that it has a lot of context about any task, right? And then it says that I can focus on some of the core concepts, advanced skills, specialization, adding personal experience, networking and portfolio, and continuous learning. So as you can see, just by writing simple prompts, you can do a lot of astonishing things, which till a few months or a few quarters back was something for which you would need a lot of expertise. And that is the power of ChatGPT with some very, very simple prompts. So before understanding what a prompt engineering is, let's understand why do we need it. Most of the times, these LLMs provide correct outputs to the input prompts, but sometimes they fail to provide correct outputs and can go wrong. For example, they are not very good at multiplying numbers and will often give you an incorrect answer. So let me take a new task, and this time I am asking the chat GPT a simple math question. What is 923 multiplied by 99,999? And let's see what it does. So it was able to give me the answer, but it's not the right answer. So let's check that on a calculator. It was 923 multiplied by. And as you can see, it gave me an approximate answer. It's not the right answer. So the actual answer has 99. What it has given me is 88. So there is an error. And that's what you need to be careful about. However, if I write the prompt again as what is 923 multiplied by 99,999, and now instead of just leaving it there, I would say let's go step by step and always write out the full number of zeros. So I'm just trying to be as explicit as possible. And this time it is outlining, but you can see that the answer is right. And so it can take a few iterations, it can take a few things to get it right. So let's look at another example, another demo where I wanted to write a poem in a particular style. So let me start a new window and let's say I say write a poem about analytics Vidya. Let's see what it does. And it was able to create a very nice poem which brings out some of the values about analytics Vidya. It tells what we usually do. So it gets a lot of things right. But let's say I want it to be written in a very different style. And let me say that. So let me say that I want this poem to be written in a different manner. So I'll just say write a poem about analytics Vidya in the style of Shakespeare. Let's see what it does. And you can see that it has changed the way it has written the poem and it's still able to do it. So as you can see, the tone has changed, the elements have changed, and it's looking a lot more similar to what a Shakespeare writing is. That's exactly why we need prompt engineering. Prompt engineering helps us to improve the accuracy of our output and also helps us in achieving the desired and specific outputs. So prompt engineering is the process of refining the prompts over iteration to get the optimal outputs. Prompt engineering is all about iterative way to improve your prompts. It's about considering how to rewrite the prompt to get better results and exploring different ways to achieve the required outcome. It's an iterative process where you write a prompt, see the result, and then rewrite the prompt again to get the desired output. And this process continues. Mastering prompt engineering comes through extensive practice and experience with these LLMs. There are some best practices to write effective prompts and methods for prompt engineering, and that will be the focus on the rest of this course. But if you're wondering what is the way forward to build LLM applications using prompt engineering, when building LLM applications using prompt engineering, you need to have access to two things: a pre-trained LLM model and the right prompts with required information to achieve the desired outcome. Prompt engineering is one of the simplest and easiest ways to build LLM applications as it does not involve any technical knowledge or coding to build these applications. This method does not involve any model training as well. And this means that you don't have to worry about the training data, or there is no need to worry about computing resources. So it's a cost effective and efficient approach. When using enterprise LLM APIs such as OpenAI or Claude, they charge you based on the number of prompts. If you opt for an open source LLM, you'll have to host the model on the cloud and access it through your API, incurring cloud costs for deployment and maintenance. In this case, you'll need to afford the cloud costs of deploying and maintaining a LLM. The prompt engineering based applications are not consistent with their outputs. There is no guarantee that the output will always be correct. It might provide incorrect outputs as well. These applications may also hallucinate, so they make up answers which is not true. Hallucination is one of the fundamental problems in LLMs today and common with prompt engineering based applications. They often make up their own answers when they don't know the information. When you're prompting ChatGPT, you might come across the problem that the message you submitted was too long. Please reload the conversation and submit something shorter. This is because ChatGPT has the restriction on the number of input tokens up to 4096. It can take and accept only these number of tokens in a single prompt. When given more than that, it throws up an error. Likewise, every LLM has the restriction on the input length. Sometimes, when you're building prompt based applications, you might want to provide more information in the prompt to these LLMs. But this is not possible because of the restriction which I mentioned. And as a result, very less information fits into a single prompt. These applications completely rely on the LLMs used and the internal knowledge gained during the training process. These LLMs have the knowledge of the training data and are not up to date. So, how do we enable external knowledge into LLMs apart from the data which it has been trained on? And that's where the next method, which is retrieval augmented generation, comes into the picture. In the previous module, we learned about prompt engineering and why it is important. We also interacted with ChatGPT through its interface. However, the interface has limitations as it only allows interaction with ChatGPT, and retrieving responses from it is not possible. Hence, it's not feasible to integrate it into applications in an automated manner. When developing large language model applications using prompt engineering, it's essential to have this flexibility to prompt ChatGPT and retrieve responses directly into your application so that you can work on it. And that is where this is made possible through application programming interfaces or APIs. An API makes it easy for developers to use specific features or access data from one application in another. OpenAI provides ChatGPT APIs for developers, allowing users to send prompts and retrieve responses directly. So before we delve into ChatGPT API, let's set up our system. And the first step is to have a Jupyter notebook. For this demonstration, we'll use Google Colab, which provides online Jupyter notebooks on the cloud. Alternatively, you can use a locally installed Jupyter notebook on your own system. So let's go to the Jupyter notebook. For access to Google Colab, you can simply go to Google and search Google Colab. It will show you the link to the Colab platform, which has the URL research.google.com. Once you are there, all you have to do is click on New Notebook to create a new Jupyter notebook. Now that we have the Jupyter notebook running up, the next step is to install the OpenAI Python library to access the ChatGPT API. So let's install the OpenAI library now. Right. Now that the OpenAI library is installed, let's import this library and add the API key which you can find in your OpenAI interface. For those of you who don't know how to get this API key, essentially you'll need to go to platform.openai.com. So once you log in, you can find your API keys over here. And by clicking it, you can see that there are the APIs which are here. If you don't have an API key already, you can create by clicking on the create new secret key and give it an optional name. So I'll just say that this is my test key and I can create my secret key. Now, ideally, you should not share this secret key with anyone. That's the reason why it is called secret key. So make a copy of this so that you have it handy when needed. This particular key I'll delete because it's not something which should be available publicly. So, assuming you have got your API key, let's move on, and our system is now ready. So you can now access Open AI interface through this API key. In this lesson, we'll explore how to communicate with ChatGPT using its API and delve into various resources. The chat completions API provided by OpenAI enables us to send prompts to ChatGPT and receive responses. It enables us to have multi-turn conversations with ChatGPT. An example API call for chat completions involve two main parameters: the model and messages. The model parameter refers to the language model we want to use, such as GPT 3.5 or GPT-4, each with different context lengths. For our demonstration, we'll use the cost-effective GPT 3.5 model. So let me go ahead and give that as a specification. So the model parameter has been defined. The second parameter, which is messages, stores all the interactions with ChatGPT. It contains the list of input prompts and corresponding output responses in JSON format. And each messages has two properties: role, which can take value either system or user or assistant, and the content, which contains the message which was assigned to the role. So let's understand the roles of ChatGPT. Now, user role represents the input prompt or the query of the user. For instance, if the user wants to ask ChatGPT for a joke, we assign the prompt, tell me a joke, as the content and user as the role. Now we pass this message and the model to the chat completions API, retrieve the response and print it. So let me go ahead and do that. Let's go ahead and print the response which we have got. So as you can see, it has told me a joke, which is, why don't scientists trust atoms? Because they make up everything. So that's how you get a response from a ChatGPT model. Now, as you can also see that the response is returned in a JSON format, which is clear over here. And that is why we needed the print statement. The JSON format also includes things like ID, object, the model used, the usage, along with the exact number of tokens which were used, so that we have an idea about the cost which is getting incurred. The answer to the exact question can be found in the content area. Now, if you notice carefully, you can clearly see that the output provided by the ChatGPT takes on the role assistant. So assistant role is defined for the response given by the ChatGPT. So coming to the next role, the system role allows you to provide system level instruction, guiding your model's behavior throughout the conversation. For example, you can say the system role that you are an assistant that speaks like Shakespeare. That will insist the ChatGPT to give a response like Shakespeare. Let's create the message with both system and user roles and see the response. So here was the message. Let's see the response. And now I'll go ahead and print it. So as you can see, the response is like Shakespeare. Combining system and user roles can yield interesting outcomes. So let's define a function getResponse, which takes an input prompt and an optional model argument defaulting to GPT 3.5 Turbo and returns the response from the chat completions API. So here is the function which I am defining. And now we can start experimenting with a few prompts. So let's start with very simple prompt. So what we are going to do is we are going to write a prompt over here and then print the response which we are getting from the prompt. Our system is set up in a way where we can continue this iteratively and see what is the outcome of these prompts. So the first prompt which I would want to give is, let's say that I wanted to write a blog post on decision tree. So what I'm asking it to do is write an article on a technical topic. And let's go ahead and see what it does. Right. So now it has written an entire blog post on decision tree. But this looks like a little bit on the higher side. So let me now change the prompt. So I'll just copy the same command, but I'll change that prompt to write a short blog post on decision tree, and I'll explicitly say limiting to 500 words. So I have now specified a limit that it should restrict it to 500 words. Let's see the outcome. So as you can see, it has given me the outcome. However, this looks very technical. And let's say if I was writing this blog post for beginner audience who wants to build their career in data science, this would look extremely difficult. So let's go ahead and see if it can simplify that. So this time what I would say is write a blog post on decision tree, but I'll specify for beginner level audience who are starting their career in data science, and I'll say limit the blog post to 500 words. So this time I have also limited the number of words and asked it to make it more beginner friendly. Let's see what it does. So now, as you can see, it has broken down the entire article into different sections. So I can see a section for introduction, understanding decision tree, its advantages, how to build a decision tree, and then the conclusion. So it has made it simpler, it has made it more sharper, and the outcome is far better than what probably, let's say, we were getting earlier. So now let's see if we can make it even better. So let's assume that I want to actually add a few more sections. So what I'll do is I'll ask it to actually add a few more sections like let's say the learning objectives of the blog post. So I'll change the prompt. So this is the new prompt which I'll give, which is essentially write a blog post on decision tree for beginner level audience, but I've specified that it should include introduction, learning objectives, table of contents, and the working and conclusion. So let's go ahead and print it. Great. So now you can see it has given very clear learning objectives along with table of contents and obviously the rest of the article. And this looks like something which can be published. However, in order to publish an article, it should also be SEO friendly. Or what it essentially means is how discoverable is this article to various search engines. And in order to do that, it needs to follow a structure which the search engines can understand, or the bots which are working for the search engines can understand. So what I'll do is I'll just add another prompt saying write a SEO friendly blog post on decision tree, and rest of the prompt remains the same. And let's go ahead and run this. So this time the output which will come would actually be a lot more friendly to the SEO bots which are running, which scan the article so that my article actually comes more frequently in the searches. So this is now the final article, which can be taken and be published. However, what I see is that we are actually missing the FAQs section. Now, every article on Analytics Vidya comes with a few FAQs. So what I want is that ChatGPT should also give me these FAQs. So let me go ahead and ask it to create or include 10 FAQs for the above blog post along with the answers. And let's see if it can do it. So now when I look at the outcome, what I see is that it has actually created 10 questions and they follow a structure which can be very easily seen. So question and answer. However, these do not look related to what we were writing. So the context got missed. However, the model understood what a FAQ is and the structure in which it could come. But it has lost the context which was there in the blog article which we had created. Any ideas why this happened? Well, the reason is that each API call which we make to ChatGPT is actually independent. And hence, it did not store the history which was there in the previous conversation. How to enable conversations with ChatGPT API while maintaining the context. So in the previous video, what we saw was that we created a blog post using the ChatGPT API. But when we followed up another prompt which included the context of the previous prompt, it did not work. So I was not able to create the FAQs for the article which I had written with the first prompt. So if you remember, the first prompt was where I had asked ChatGPT to write the article. And this was the output which we had got from the ChatGPT at that time, with table of contents, learning objective, and a SEO friendly blog. And the second prompt which we had given was include 10 FAQs for the above blog post. And what it did was it gave me 10 different, very unrelated FAQs. So it was still able to maintain the structure, but it did not carry the context. Now, in order to do this, what we are going to do is, first of all, we are going to create a list called messages. So let me run this. I define first prompt output and I've defined second prompt. Now what I'm doing is I'll store all of these prompts into a list along with the relevant roles. So the first role was user because this was the prompt given by the user. The second one was the output which was created, so hence the role of assistant. And finally the second prompt again with the role of user. So we create this list. So now what I'm going to do is I'm going to pass this on to ChatGPT 3.5 Turbo along with the messages. So all the history gets passed on in form of these messages. So let me go ahead and run this and then print it. Right. So now you can see that all of these FAQs are related to decision trees. So we are able to maintain the context by use of this list which we had created. Right. So now I have an exercise for you. So let's say that you want to add an illustration to the same article. And what I want you to do is write the third prompt as an exercise. And in order to do that, you will actually need now a longer message which has the second prompt output as well as the third prompt input with the associated roles. So go ahead and do that exercise so that you get the exact answer to how to maintain this context. Obviously, once the messages are there, you'll need to run it and send this to ChatGPT 3.5. Now, assuming you are able to do it, you would be able to see that this becomes very tedious very quickly, right? So if you are, let's say, working on an application where there are hundreds of these prompts which are getting generated, you cannot keep adding those in this manual fashion. So what we need is actually a automated way in which all of these prompts and their outputs get added to the history. And that is what we'll do next. So what we do is we create an empty list again by the name history. And what we then do is that all the user input prompts are added with the role user into history. So we append every time there is a new input message, we append that to history. And then we pass it on to ChatGPT. And finally, whatever output comes, we add that again to history, but this time with the role of an assistant. So let me go ahead and execute this. Now, once this is there, let me show how we can carry this context in an automated manner. So I am going to take a different example this time. What I want to do is actually write a welcome message for all our analytics with their community members. So I go ahead and give this prompt. So now, as you can see, ChatGPT was able to create a good welcome message. It tells what all people can do on Analytics Vidya and a bit of what Analytics Vidya is. So a good start, but what it does is it is not giving very specific actions. What I want is that this welcome message should have very clear specific actions which the user can take so that they can interact with the community. So what I do is I pass on the second prompt, which is along with this welcome message, what I want is that the specific next steps can be added. And I again pass that as a user prompt. And finally, let me see the output for the same. Right. So what ChatGPT has done is it has given a very specific set of instructions to the user along with the welcome message. Now, while this works, what it has done is it has taken a message which was, a welcome message, and it has made it very specific. What I want to do is I want to actually add a story of how community has helped some of the community members. So what I'm doing is adding another prompt where it is adding to this message further. So I'm saying that add a story to this message, which shows the impact of community and learning in the life of a community member. And I still want it to end the message with specific actions. So I pass this new prompt to the chat function, and let's see what is the outcome. Right. So as you can see, ChatGPT created a story of a user, John, who was a software engineer, and then explains the specific next steps which the users can take. So this is now a good welcome message where I was able to build on the context. And in order to see the history of prompts we have seen, let's go ahead and print that. So you can see that there were different prompts which were given in different roles. So user assistant, which was the output, again user assistant. So this was able to do it and maintain the context. Now let us say that we have finished this task and I want to now do a new exercise where I want to write a message to the community members the very next day about importance of daily learning in data science. So now I don't actually need the history. So I want to clear up the history. And for that, I'll pass on an additional parameter, which is the value of it is true. What it essentially does is it would clear up the history. By default, it is false. It would essentially clear up the history so that I am starting a new task. Right, so here is the new message. And as you can see, this is completely new, doesn't carry over any context. And just to see that, let's go through the history. And as you can see, the history only has one input and one output, nothing else, right? So just to recap what all we have seen till now, right? So first of all, we were able to create a programmatic interface to ChatGPT. So we were able to get an OpenAI API key for yourself, and we were able to connect to ChatGPT. We were able to give these prompts to create outputs, and we can do that by preserving the context and without preserving the context. We also saw what were the various roles, so user role, assistant role, and system roles, which help us in maintaining this output and learning through the program. Along with that, we saw how we can enable the history or clear the history. So now you have almost everything you need to play around and build a few basic applications. So go ahead and build a few applications which you think can be of interest to you. So far, we have discussed how to effectively craft the prompts using ChatGPT API, a proprietary and closed source large language model or LLM, which is developed by OpenAI and it's known for its exceptional performance. Now, there are some benefits which you get by using these closed source LLMs like ChatGPT, which is that these are state of the art. So right now the performance which GPT is providing is way better than any other model out there. So you can access the state of the art at a fraction of the cost, and they are great to get started. And when you don't have a lot of context in the domain, or you don't want to make upfront investments and commit to a large sum of money, these are great way to start. However, as you scale, there are some challenges which you might run into. The first one is about data privacy. So, different organizations or enterprises have their own data policies, and you may or may not be allowed to share this data with OpenAI. So, if that is the case, you cannot use ChatGPT and the APIs which it provides. Similarly, as you scale the model, and if you want to run this at a large scale, you would incur very high costs without actually developing the technology. So, this becomes prohibitive as you scale up the use cases. And this is where open source LLMs can come into picture. Open source LLMs stand out for their accessibility as these models are freely available to everyone. Users can access, use it for any purpose, modify, and then distribute the model's code and architecture. This open source approach actually offers great flexibility for developers and researchers, and it also provides a very transparent way to build these products. Some of the popular examples of open source LLMs are Mistral 7B, Falcon 40B or 180B, Starcoder, Llama 2. Amongst these, Llama 2 from Meta AI is the most notable example. Meta AI has open sourced the entire model architecture and its weights. And the model is available in variants like 7 billion parameters, 13 billion parameters, 70 billion parameters. So, all of these versions are available for text completion and for instruction following. You can explore these models at Hugging Face, and the link is there in the description. So let's delve into how we can prompt Llama 2 effectively and build our applications. In this lesson, we'll set up our machine to build an application using one of the open source LLMs, Llama 2. And in order to do that, so we again open our Google Colab. But this time, what we need to do is we need to change the runtime type. So we go in runtime, and there we say change runtime type and convert that into a T4 GPU. So we would need GPUs to essentially load the open source model. So that is why we need to make this change. So we choose the right hardware accelerator. And the next step is now to install two libraries from Hugging Face. So these two libraries are Transformers and Accelerate. So let me essentially install the two libraries. So as you can see, Transformers is now installed, and so is Accelerate. So once the two libraries are installed, Transformers and Accelerate from Hugging Face, you would need to request for the access to Llama 2. Now Llama 2 is an open source model, but Meta is still asking you to request for the permission to access Llama 2. So you'll need to provide some details about yourself and the models you need access to. Go through the terms and conditions outlined over here and apply. Once you apply, Meta would essentially provide you the access. And this model is hosted on Hugging Face. So you would need to essentially go to Hugging Face. And once you are there on Hugging Face, it would again ask you to essentially apply for accessing this model on Hugging Face. The key here is that the email ID which you use to ask permission from Meta should be the same email ID with which you sign in into Hugging Face. And again, you can say that I agree to share my name, email address, and submit this. It typically happens instantaneously, even though what they say is that it may take 1 to 2 days, right? So, two steps. First, request for access. Once you've got the access, you would need to essentially go to Hugging Face and get your access through Hugging Face. Now, once that is done, you would need to create a token. And to create the token, again, you will need to go to Hugging Face and settings token. And over here, you'll need to create a new token. And you can say what role you want, read or write, and generate a new token. Once that token is generated, you would need to essentially put that in this command over here so that it can essentially be used to access the model. So this is what you need to essentially set up the model. We now move on to actually loading Llama 2 onto your local environment which you have. So let's start from there. So you start by importing auto tokenizers and essentially torch libraries, and you need to specify the model which you want to run. Right. Once that is done, we need to essentially load the tokenizer, which is essentially a pre-trained tokenizer, which includes all the tokens about on which the training has been done before. So this is getting loaded. And once that is done, we'll also need to essentially download the pipeline. So we are doing that as the next step, which essentially enables us to do text generation on Llama 2. And as you can see, it is essentially downloading this model. You would roughly need about 12, just higher than 12 GB of RAM to essentially download this model. Now, once this is done, we can then start using this model for our prompts and getting the response from there. So let's wait while the model is getting downloaded. So now what we see is that the model is about to completely get downloaded. And just to reiterate, what we have done is we have downloaded the entire model into our local environment. And what that enables us to do is now anything which we do is happening in our local environment. We are not passing on our data to, let's say, ChatGPT API or any external model. Whatever data I am generating remains in my environment from now on. So let's go ahead and define a function which essentially accepts the prompt and returns the response, which should be very similar to what we did in using ChatGPT. Right? So again, we define a function which is called getResponse. Again, there are multiple parameters. What is key here is max length, which is the maximum number of output tokens which you would want in your model. So we define getResponse, and again prompt is the input, and we essentially get the sequences of generated text. So once this is done, we would now need to understand the prompt template, right? So the model has been trained using a specific template, and each model has its own template. So Llama 2 has its own template. If you pick up any other model, it would have its own template. So let's just spend a few minutes understanding what this template is looking like. So it has a special token S which starts and ends over here. And then you have to provide the instruction within these brackets. So the start is inst and the close is /inst. In between this, you have to provide the instruction. And the instruction itself, you could have system prompt, which goes in between sys and /sys, and the user message goes here, right? So this is the template in which the model has been trained, and all our prompts to the model need to go in the same template. So this is something which you will need to look at every time you do a different model. You have to make sure that the prompting is in the template which is provided along with the model. So let's say in this case, I'm starting to play around with the model. So the first prompt which I do, and again, it is in the same template. So within the system prompt, I'm saying that you are a helpful, respectful, and honest assistant. And I'm setting up some expectations in terms of how I want it to behave. And the specific prompt which I say is I liked Friends and Money Heist, which are two of the most popular web series. Recommend me the similar shows to watch. Again, very minimal context which has been provided. The model would rely on its knowledge base to see what is Friends and what is Money Heist. And let's see what is the outcome by printing it. So you might see that there is a marked difference in the time it essentially takes to get the response. This is because this is now happening on a cloud hardware, which is in this particular case Google Colab environment. And that is why its performance may not be comparable to, let's say, what we have seen on ChatGPT. Right. So here are some shows which it has been able to provide. So what we can see is that the model can interpret simple commands and give us the right responses. Now, let's take a case study where we are essentially translating different product reviews. So, what we have is a set of product reviews, and they are in different languages. Like in any multinational company, you could have reviews in different languages. What we want to do is take all of the reviews and then essentially translate them in so that people can understand what those reviews are saying. So that's what we will try and do. So the first thing which we want to do is just see whether we can use Llama to do some simple translation. So what I'm doing is I have just, along with the prompt which I had given, so there is a system prompt. I'm also giving a user prompt. And in this user prompt, I am simply asking it to convert a French sentence into English. And let's see what it does. Right. So, as you can see, it has been able to convert this French statement into English, and the user seems to be fairly happy. Now, given that we can do this, let's try and build a more generic translator, sort of a universal translator. So, there are, let's say, reviews in different languages, and these are some of the reviews which we have. So, I'll just create a list, and then what I'm doing is for each review, I'm passing on a prompt where I say that translate the given text in delimiters into English. So again, delimiters, as you would remember, help us just structure the prompt better. And once we have a particular prompt, I'm asking it to print it in a particular format where I'm saying what was the review, what was the output, and move on to the next line. So let's see, it was able to convert the first one into English, and looks like it is translated. Same thing in the second and the third review. So what we have done is by simple prompt, we have actually created a universal translator where you just give the language without specifying what language it is. The model was able to use it and translate it and give us the output. Let us try further different language, and this time what I'm doing is I'm saying that translate the following text into Spanish and German. So I'm seeing if it is working with languages other than English as well, and let's see what the model does. And it was able to do that, and it also made a small note for you. So by simple prompts, we have been able to create a system which can translate any language into any language. And here is one which is translating it into Hindi. So now this time when it is translated it into Hindi, you can see that it was not able to translate the same sentences, and there is a reason for it. And we have seen this reason before. It is because when we do API calls just directly with the prompt, the model does not carry the history messages. So the same problem which we saw with ChatGPT also happens in this case. So what we need to now do is we need to pass on the messages, the history messages along with the model. And that is what we'll need to do when we want to enable the conversations using Llama 2. Guidelines and best practices for prompt engineering. As you might have noticed by now, prompt engineering is as much an art as much it is science. So you need to iterate, you need to find out what are some of the best ways to get the most out of a large language model like ChatGPT. So in this module, we'll go through some of the best practices which we have learned by our experience, which help you get the most of the output from these large language models. So in order to set up, what we are doing is something which you have already seen. So we have installed the OpenAI Python library. We have also imported our API key, and we are defining a function which is getResponse with the prompt and a new parameter which you have not seen till now, which is temperature. I'll explain this later in this module. The model is GPT 3.5 Turbo. So for every input prompt, the role is that of user, and we are sending it to chat completion API. And whatever response we get is essentially the final response. So let me go ahead and run this function. Now, in order to make this module extremely useful, we'll look at a case study where we want to use a large language model. So this case study is for a customer support function. So think of it like a customer support which gets multiple tickets in form of emails. So there are several emails which the users can send to this customer support function, and the customer support function is expected to categorize these tickets into different categories, whether it's a usage problem or a technical problem, or let's say a billing related problem, and then resolve those tickets as needed. So what we would do is see how you can use prompts to make their responses faster, make their categorization faster. And this also brings out one of the key advantages of using LLMs, that in order to do this, in order to do this classification and resolution and creating these messages, you actually don't need any training data. You can just use what ChatGPT has already been trained on. So here is a first customer support ticket and a sample of what these tickets could look like, right? So you can see this is a email which outlines the problem, some details about the user, and then what they've tried doing. So let me save this as first customer support ticket. Here is a second one, and I'm saving that as second customer support ticket. So again, in this case, the user has highlighted the issue, the feature which is getting affected, and a few more details. Now, what we want to do is, let's say we want to classify these tickets. And in order to do that, let's say I start with a simple prompt which says classify the customer support ticket. And then I'm doing first customer support ticket. And let's see what is the outcome from this prompt. And as you can see, the model says that the customer support ticket can be classified as a technical issue. Now I go ahead and I say that classify the second ticket for me as well. And this time it says that it has a technical issue related to inability to access a specific feature. Now, what is happening is while the model is able to summarize what the ticket is about, it is not using consistent classification. So it has created a class which is, let's say, technical issue. It has also created a class which is technical issue related to inability to access a specific feature. Now imagine what would happen if there were millions of such tickets. There will be so many classes that it ends up defeating the whole purpose, right? In all likelihood, you need this classification because there are different people who can deal with these tickets based on this classification. So you ideally want it to be classified in two or three different tickets. So what we need to do is write that specific instruction to the model so that it can do exactly that. So what I'm doing is, now instead of saying that classify these as the default prompt, I'm saying classify these support tickets into broad categories such as technical issues, billing inquiries, and product feedback. Now, depending on the use case, there could be a few more classes, but it should suffice what I am trying to do. So, in the first particular ticket, it says that it is a technical issue. Similarly, on the second one, now it should give me a consistent category, which is technical issues. So by giving a very specific prompt, I'm able to categorize these into specific functions, and then I can forward these tickets as needed. So now let's go a step further, and let's say that now you want to generate a response to these tickets, right? So again, I start with a simple prompt saying generate a response for the customer support ticket related to the user experiencing issues with accessing their account. So I run this, and again, what I see is that it has given me a response. It is giving me the ways to investigate further. In the meantime, it is also again adding a few troubleshooting steps. It is not very clearly in a structure where I can say these are the steps to troubleshoot. And also, again, as a company, we want to reassure customers that their data is secure with us, and also give them a prompt resolution time. So again, what I'm doing is I'll make my prompt a lot more specific. So this time I'm saying generate a response, but include specific details such as steps to troubleshoot the problem, reassurance about data security, and a prompt resolution timeline, right? And when I run this, now you'll see that in the response, the model is able to provide all the things which I asked for specifically. So here are the steps to troubleshoot. It again gives a reassurance about data security, and finally adds a timeline, right? So the first step is to make sure that your prompts are as specific as possible so that all the context which you have gets transferred. Outcome from the model is what you exactly need.